Hello and welcome to today's video. Today's video is to go over some of the proofs that go with section 3.1, properties of parallel lines. Okay, so you should have the notes from the previous video, and I'm just going to go through and do the proofs, and I'm going to add one proof at the end. So if you take a look at the notes, they talk about a transversal and the different types of angles. Make sure you know those. Also, make sure you know the theorems. There are 5 theorems that go along with parallel lines. Each one of these theorems or postulates, you have to start with parallel lines, and then they tell you something that's true about various angles that are in those. Okay. So we're going to prove, we can't prove the corresponding angles postulate, that's why it's a postulate. So we want you to know which one is the postulate, because you can think of this as like the keystone. This is the one that all the other theorems in this section are based on. Now this one makes sense if you think about it. If we have 2 parallel lines, the corresponding angles are going to be congruent. And the way we like to think about this one is if we have 2 parallel lines and then we have a transversal that cuts them. If you took those 2 parallel lines and you smushed them together until they finally became one line, what would happen is the 2 corresponding angles, suppose angle 1 and angle 2 over here, would get smushed into the same angle. So suppose that's angle 3 now, and they would be the same angle at that point, so they would be congruent. So I can give you an explanation on why corresponding angles work, but we can't prove it. But we can prove all the other theorems in this section using corresponding angles postulate. So we need to know that it's the postulate and it's kind of the building block, the keystone of what we're going to do. Okay, so the first proof I'm going to do is I'm going to prove theorem 3.1. If a transversal intersects 2 parallel lines, then alternate interior angles are congruent. Okay, so I'm given the lines are parallel. That's very important for section 3.1. You have to be given parallel lines, and we want to prove that angle 1 and angle 3 are congruent. So statement, we're given, so we'll start off with those. And now here's where the corresponding angles come in. I like to start with corresponding angles because I know it's going to be my building block. So I'll look at the picture and I'll say, what corresponding angles do I have? If they're not labeled, I can, if I want an extra angle in here, I could put another angle in it, call it angle 2 or angle 5 or any number that's not already being used. If I take a look at the picture though, I can see that angle 4 and angle 1 are corresponding angles. So my first step is I'm going to use corresponding angles postulate, and I'm going to say that angle 1 is congruent to angle 4, and my reason is corresponding angles postulate. Okay. Now if I come up here and look at what I'm trying to prove, and I take a look at what I have right now, I see that angle 1's great, but I need to get rid of angle 4 and I need to replace it with angle 3. So if I come over here and I look at those 2 angles, there's angle 4, there's angle 3, I can go, oh, they're vertical angles. So I can use vertical angle theorem, and I can say that angle 3 is congruent. Oh, let me get rid of that arrow. Angle 3 is congruent to angle 4. And this is vertical angle theorem. Okay? And now I have 1 is congruent to 4 and 3 is congruent to 4, so I can say that by the transitive property of congruence, remember there's no substitution in congruence, but I can use transitive. Angle 1 has to be congruent to angle 3, and this must be called transitive. Transitive property of congruence. Okay. And I take a look, I've proved what I needed, check, all done. Okay. None of these proofs are much harder than this. The supplementary ones are a little more difficult, and I'll do one example of those, but here's the first one. Okay. For this proof, since it's another alternate interior one, I'm going to leave this one, and if you need help with it, come see me at some point and I can show you how to do it. But I want to do one of the ones that is a supplementary one. So at the bottom of the paper, I am going to prove the last theorem. I'm going to prove the same side exterior angle theorem. Okay, so this one I don't have anything to start with, so I'm going to start with a diagram. I want to prove that same side exterior angles are supplementary, so I'm going to label 2 same side exterior angles. Okay. I need lines, so I'll call this N and M. Okay. So in order to do this proof, notice the hypothesis is if a transversal intersects two parallel lines. I have to be given parallel lines. So I'm going to be given N is parallel to M. And I want to prove that the same side exterior angles are supplementary. So I actually want to prove that angle 1, measure of angle 1 plus measure of angle 2 equals 180. Okay, and so I need my statements and reasons and ... given. Okay. Now, everything always comes back to corresponding angles. So what I'm going to look up here, and I'm going to label another angle that would be corresponding to either 2 or 1. So how about I'll label this angle right here 3. Okay. Now, once I label it in my picture, I can use it. So I always start out with corresponding angles. So I'm going to say angle 1 is congruent to angle 3. My lines are parallel, so this is corresponding angles postulate. Now in this case, I'm not going to get another congruence and then use transitive. I somehow need to get to a supplementary statement. So if I take a look up here and I look at my angles that are labeled, I can see that if I take these two angles, they have to be supplementary because they form a line. So remember, we're allowed to assume adjacent supplementary angles, and so I can say they're supplementary, and my reason is definition of supplementary angles. So I can say measure of angle 2 plus measure of angle 3 equals 180, and my reason is definition of supplementary angles. So now I at least have my supplementary statement, but angle 2 is great. I need to take out angle 1 and I need to replace it with angle 3. Okay, so this one here and this one here need to swap. But if you take a look at my corresponding angles postulate, it gives me that swap. But I'm substituting into a mathematical statement, so I need to change it to equality. So I need to say that measure of angle 1 equals measure of angle 3 before I do that substituting. So this is definition of congruent angles. And now I can take out 3 and put in 2. So measure of angle 2 plus measure of angle 1 equals 180. Substitution property of equality. You can also call it transitive property of equality. And in this case, I'm done. You don't need to switch the measure of angle 1 and the measure of angle 2. It's the same, it equals 180, and so I am done with this proof. So some of your homework tonight is, I believe, to try some of these proofs. If you have any question on them, please make sure you ask. The next section is going to be all the theorems that we learned in section 1 except for all the converses. So definitions are always reversible, and you can just write the definition and it's reversible and you can use it either way. Theorems and postulates are not. If a theorem or a postulate has a converse, then we actually have to have it as a new theorem with a little converse at the end, and then we can use the converses. So that's all about what section 2 is about, using it to prove lines are parallel. Thank you for watching. Have a great day. Bye.